everyone. I'm Sharanya PS, Assistant Professor, Department of ISC, AJIIT Mangalore. In this video lecture onwards, I'm discussing the continuation of Module 4. The topic is Multithreaded Programming. In the series of previous lecture videos, I have already covered the Module 5. Now let us begin with these concepts. Here, now I will be covering what is meant by a multithreading, what are the different ways this multithreading can be implemented with example programs. Along with that, we will cover some of the basic information about multithreading. First thing, what is meant by a multitasking? Before understanding multithreading, let us first clear about what is meant by multitasking. As we know, task is nothing but some small work. Here, multitasking refers to a process of executing multiple tasks simultaneously. At a time, the CPU is allocated to execute a different kinds of tasks so that the utilization of the CPU will be high. We can engage this CPU to be busy in one or the other completion of the task. How it can be performed? This can be achieved in two ways. One is process-based multitasking, that we call it as a multiprocessing, and one more as a thread-based multitasking. This is also called as a multithreading. Now we'll see what is these two types. By both of this we can achieve multitasking. What is meant by a multiprocessing or process-based multitasking? First thing, what is meant by a process? The program under execution, we call it as a process. Here, when we execute any program, it will be that need to be loaded onto the CPU and then it need to execute. That time, the program will convert it into a process. And what is this multiprocessing? That is, at a time, if the CPU is allocated to execute that by multiple processes. That is, in a CPU, if multiple processes are executing, then this multiprocessing will come into picture. That is, suppose in simple terms, if we engage in two different tasks, say for example, we may browse in the Google, parallelly we may be listening to the music. There we could see two different processes. One is browsing it in the Google and one more is a listening to the some audio. Now the computer or the system, in the sense CPU is busy with executing two different processes. One is browsing, that is it need to manage the browser process, and one more managing this video or audio playing. This is how this multiprocessing will going to work. Two different processes are going to execute at a time. So here one more example, what it says is writing the Java program in a text editor and listening to the music. We all come across this kinds of systems usage with multiprocessing. So these processes we normally call it as a heavy weighted task. What is this heavy weighted task? If it is a process that suppose I think that there is two different processes. One is executing processing with the browser, and one more is used for music. So here now we could see two different processes are currently running. Now how it become as a heavy weight? When we refer it as a multiprocessing, processes have its own address in the memory. When the program get converted it into process, it will be allocated with the address in the memory. So here it is executing two different processes, so separate two memory areas will be present. That's why the memory consumption will be more in two different memory locations. That is the one point. Next, here the inter-process communication is expensive and very limited. That is, if we want to get communicated between the browser what I am accessing currently and between the music player, there might be a lot of communication need to occur. It may need to access a location of the address location where it is executing or where it is stored. All those backend process need to be performed. That's why this inter-process communication is very difficult. And one more, there is one concept called as a context switching in operating system. What is that? That is, currently one process is executing in the CPU, that it will be removed and one more process is started its execution. That is, new process is loaded for the execution. That is switching from currently executing process to some other process. That we call it as a context switching. That is, here if we want to parallelly execute both the programs, the switching or context switching in the CPU is high. It requires a lot of information to be stored parallelly when this context switch is getting occurred. So these are all the much work is required when it is performing as a multiprocessing. That's why these processes are normally multiprocessing is all normally call it as a heavy weighted task, or this process we normally refer it as a heavy weight. Now coming to the thread. What is meant by a thread? First point. Here a small unit in the process we call it as a thread, or a small part of the this entire process we call it as a thread. So how does if we take it as an example, suppose if I am working in a Word document where I will be keep editing some contents, parallelly I will be printing the document. So in the same Word document editor, two different tasks are currently running. Those two we refer as a threads. That is, one is what I am doing as a editing, parallelly I am printing. So first task, that is acting as a thread which is editing, and second task which we refer it as a printing, that acts as a second thread. So what we refer here is a thread is the smallest unit of a dispatchable code. That is, here rather than executing the entire process, this process is divided into a smaller units, and these units are executed so that the entire completion will be much faster. That is the concept of this multi-threading. How the benefits, or why it is called as a lightweight? Because here if we refer, I am referring with the same Word document and I am working with the two different tasks. I will refer this as the that is typing as a first task and then printing as a second task. These are the two different tasks which is currently running, but it is running as a part of this Word application or this Word process itself. So here it shared the same address space, that is T1 and T2. These two tasks will is a part of the same process, so it is sharing the same address space. And here obviously there won't be much overhead when it performs a multitasking. That is, each time when T1 is execution, after that T2 might be start its processing. And here the communication between these two threads is much more faster and inexpensive because both are stored in the same address space. So it no need to fetch the address location to communicate between those two. It is much more faster. And one more, to perform the context switching is also much easier because it is a smallest unit. So context switching will be much faster and it is a low cost. These are all because of these features. These threads, we normally call it as a lightweight task. These are the difference between. Now we'll see why these threads are called as a lightweight, and we saw why these processes are called as a heavyweight. Now we'll see the difference between process-based and thread-based multitasking. What we have discussed, I have summed up in a table. What is this heavyweight task? This process-based is a heavyweight task because they require their own separate address space. That's why main here is this heavyweight task. What we call this process-based is because one reason is they require their own separate address space. As we discussed with the example, they are stored as a two separate processes, so it will acquire the two different memory location. And coming to the thread here, they share the same address space because it is working under the same process. And here one more second difference is inter-process communication is expensive and limited in the process-based. It is much difficult since two processes are stored in a separate memory address space. Whereas in the thread-based inter-process communication, that is nothing but we refer it as a inter-thread communication is much more faster. And here in the process-based, context switching from one process to another is costly. Whereas in the context switching from one thread to the next is much more low costly. That is, context switching will be much faster in the process based, whereas in the thread based it will be much difficult. These are the major three difference between the process based and thread based multitasking. Now we have discussed what is meant by this multi-threading as well as multitasking. Now we'll try to define properly what is meant by a multi-threading. We might have come across, that is, like we might be opening the browser, and there in that browser we may be opening a new tab. Parallelly in one more tab we may start downloading some file. In that particular scenario, we could see that process is nothing but that browser what I am using as an application. That is the main process which is currently executing. In that, I have opened a new tab that is acting as a thread. That is the smallest unit that is executing in the main process. And I started downloading some file in that thread. That is one more task what is going to be occurred in the main process. So there we could see three different kinds of operations. One is the main process. Under that, two threads are currently running. So this is what we refer as a multi-threading. In other terms, if we consider the Word document, the same way, we could observe the different smaller tasks what is going to occur in the main process, that we can take it as a threads. Threads we call it as a lightweight because of many reasons what we discussed. Multi-threading in Java is a process of executing multiple threads simultaneously. We are clear what is meant by threads now. So what is meant by this multi-threading? That is, at a time if more than one threads are concurrently started executing, then we call it as a multi-threading. Here, what we refer as a process is divided into subprograms which are implemented at the same time. These subprograms what we call is normally as a thread. And these what we refer as a thread is a lightweight sub-process, and it is the smallest unit of a processing. Here, if you look into the diagram here, these are all what we call it as a process. It is a heavyweight processes, that is, it requires a separate memory to store all those. Whereas this, what next we'll see what are the benefits of this multi-threading. First, this enable the programmers to do multiple things at a one time. That is, because threads are continuously executed, here at a time we can programmer can focus on multiple things. That is, suppose if I give one example, there is a one program which need to print a large set of numbers, maybe from 1000 to million, and after that it need to find the multiplication or table of those numbers. In such cases, if we write one by one programs, in the sense if we call with the methods, it will take a lot of time to finish that entire program. In such higher end programs, we can make use of this threading concept. How it will work? That is, we can divide that larger program, that is maybe execution from 1000 to some lakh, it will be executed by one thread. We will call, we can create a new thread and we can ask the thread to execute that section. Like that, we can divide that entire big program into smaller, and we can enable the execution of those part from the thread. That is, here the main agenda here by using this multi-threading is dividing the larger program into multiple independent threads and executing them in a parallel, so that final resultant what we are getting will be much more faster. Otherwise, we have to keep waiting for the completion of the previous program, and then it need to proceed with the next program. This can be overcome by using this multi-threading. Next, involve a performance of concurrency, and obviously with these two statements, it is clear that the performance will be much more and concurrency will also be improved, since it is all set of codes will be executing much faster. And one more, simultaneous access to multiple application, because here it is done as a multiple threads are responsible for execution at a time. Much more applications can be executed. Now all the systems are coming in a multi-cores. So in such application, these all the programs are running as a multi-threading, because a small part of the program will be executed in one UL. Like that, we can divide it and start giving these threads for the execution of the CPU. And here also, this suppose if we take the example of some application, in application execution also, at a time if we cannot perform two different operations, maybe browsing of or searching of some items in the cart, parallelly we may need to check the what is the current trends. So those two may be working as a separate threads. These are the some of the benefits of using multi-threading, and as we observe, which will definitely help for the best usage of the CPU and faster execution of this entire process. And how this Java thread model is there? What is the way how this Java uses this thread? Even in the Java, we are coming across this multi-threading. First, it was using a single threaded system that it was the concept what it was used to implement this single threaded system is called as a event loop with pooling. That is event loop with polling. That is, here the single thread of control runs in a infinite loop and polling a single event queue to decide what to do next. That is, it will be keep executing a one thread, and if any new request arises, only during that time it will poll to which particular event it need to give. And one more point here, this polling mechanism returns by saying which is the current. Say for example, there is one task it is currently executing. It cannot preempt that task. It need to wait till the completion of that thread. After that only it will go to the next thread execution. That was there in the single threaded system. Say for example, if one thread is responsible for event handling, then it need to wait till that event is getting triggered, and then after that handling that, then only it can move to the next thread processing. That was there with respect to single threaded system, which waste a lot of CPU time. So here in general, if we say this single threaded environment is a it is mainly thread blocks. There was some block occurring because it was waiting till the completion of the current thread's execution. After that only it was going for the next thread execution. That's why there was a block with respect to the threads, and there was a waiting will be much more if some threads are doing some other work and the resource is currently not available. In such case, delay will be much more. So these are some of the problems that it is encountered in single threaded environment. Here, if we look into the thread's life cycle, what are the different states it will be once the thread is created? This resembles to the process life cycle. Here, coming to the very first cycle, when the thread is created, it is in the new state. This thread is created with the function start, and soon after the creation, it will be initially in the this new state, and then after that it will be moving to the runnable state. That is, runnable state is the state where it is ready to execute by the CPU. It is waiting for some resources to get. Once it is obtained, it is going for execution. That is, from runnable it is moving to the running state. That is like something here, it is in a thread pool. It is waiting for its turn. Next, from the running state, if we want to revert back onto the runnable state, there is a function called as a yield, which is responsible to move the thread from running state to back to the runnable state. Suppose if some suspend function is called, if currently the thread is running, if suspend function is called, then the thread will be moving to the blocking state. And if suppose sleep function is called, then it will be moved to the sleeping. That is, in a waiting state it will be there. And if wait function is called, it will be in a waiting. Sleeping, suppose if we are calling the sleep function, this thread will be in a sleeping or in a waiting state till that sleep time, whatever it is mentioned in millisecond, is getting terminated. Till that it will be in sleep state. After that it will execute its next set of steps. Here its corresponding suspends, if we call this suspend, the current running thread will be moved to the blocking state. From there, if we want to resume back to the runnable state, we can make use of this resume method. This is reverse of the suspend. In the same manner, here with respect to wait, its reverse, we can use it with respect to notify and notify all methods. From running state, it can move to the terminated state by calling the terminate function. or from any function, maybe from waiting it may move to the terminate state at the call of the terminate function or stop function. These are the different states of a thread where it exists once it starts from the start to the till the termination. And next, what we see as a thread priorities, that is which thread need to be executed, that will be encountered or decided based on this priorities. As we observe in the very real time, there are a lot of priorities that we observe in day to day. That is, suppose if we come across with the admission, there will be some priorities given with the highest rank, and then for some allotted categories, and then for some other categories. Like that, if there is any higher priorities candidate comes, for them the preference will be given more. The same way it is applicable with respect to threads. That is, here it assigns, this Java assigns each thread a priority that determines how this thread should be treated with respect to the others, like whether to give the more priority compared to the other threads when it starts its execution. And these are all the integer numbers that specify relative priority of one thread to the another. And it is more important when we are performing the, like when that process does this context switching. That is, when CPU want to terminate the current execution of the thread and it need to give the chance for the next thread. During that time, to decide which one to preempt, that time there's a thread priority can be used. And the rules to determine when the context switch is taking place, how it can be used. Two rules are mentioned. One is a thread can voluntarily relinquish the control. That is nothing but here there is no restriction, that is explicitly yielding or sleeping or blocking on pending input output. Here in this scenario, other threads are examined and the highest priority thread that is ready to run is given the CPU. That is, whichever the currently running thread is there, which is ready to terminate or which is about to terminate, that will be given with the highest priority along with the consideration of the priority number. That is, as we observed in this. Based on that, we will be voluntarily terminating. One more case is a thread can be preempted by higher priority threads. That is, in this case, a lower priority thread that does not yield the processor is simply preempted. That is, no matter what is doing by a higher priority thread. It is nothing but higher priority thread wants to run, it does. That is what it says as a preempting. That is, if there is any currently running whichever the thread is, if there is any other thread with higher priority comes, then the currently executing thread will be preempted. That is stopped, and the thread with higher priority is gone for the execution. That is what we refer as a preemption. These are all the same concept what is discussed with respect to the process, which holds good with respect to thread as well. Then, if we say it as a multi-threading, obviously there is a big question, how about the synchronization? How there is a proper coordination between multiple threads execution. That is, when we start to have more threads within a program, there might be a situation when multiple threads try to access the same resource. And finally, then no threads may get the actual resources. So, for example, there is a one file that all the threads are trying to access the same file and trying to modify that data which are present in that file. So, there might be the chances of overwriting or corrupting the data present in that file, or it might be difficult for opening the file at all the time. concurrently by all the threads. And there is a need to synchronize the action of multiple threads and make sure that only one thread can access the resource at a given point of time. This implementation is done in Java by using the monitor concept. That is, once a thread enters a monitor, all the other threads must wait until the thread exits the monitor. That is, monitor is something like a method where once it is thread is enters to the monitor, all the other threads, whichever it is remaining to be executed, it need to wait until the current running thread comes out of that. The concept what it uses, we refer it as a monitor. So in this way, monitor can be used to protect the shared assets from being manipulated by more than one thread at a time. As I gave the example there previously, here if we consider with respect to the document, any file that can be secured. Each object in a Java is associated with the monitor, which a thread can lock and unlock. And here, once the thread is inside the synchronized method, no other threads can enter to that. Next one, what we refer it as a messaging. That is to communicate between the two threads. Here, Java provides a very clean and low-cost way to for two or more threads to talk to each other by using a predefined methods that all objects which have, so that the thread to enter the synchronized method on the object which will be allowed, and then wait there until some other thread explicitly notify it to come out. This is the one way how this messaging is implemented. Thank you for listening.